안녕하세요. 커피바이입니다. 커피의 향미를 물리화학적으로 풀어낸 과학자 크리스토퍼 핸든. 그는 미국 유니버시티 오브 오레건의 화학과 교수이자 전 세계 바리스타들과 로스터들이 주목하는 커피 과학의 선구자입니다. 핸든 교수는 에스프레소 추출이라는 난제를 수학적 모델로 분석해냈고 커피에 사용되는 물의 미네랄 조성이 추출 효율과 향미에 어떤 영향을 미치는지를 과학적으로 증명해냈습니다. 이 연구는 세계 여러 로스터들이 자신만의 브링 워터를 설계하게 만든 결정적 계기가 되었고 물 역시 커피 레시피의 중요한 요소로 받아들여지게 만들었습니다. 또 하나의 중요한 성과는 바로 RDT, 로스 드럼렛 테크니크입니다. 이 기술은 커피를 분쇄하기 전에 아주 소량의 물을 온도에 분사해 정전기를 줄이고 보다 균일한 분쇄와 추출을 가능하게 합니다. 이 간단하지만 혁신적인 방법은 전 세계 수많은 바리스타들이 일상적으로 사용하는 기술이 되었고 핸든 교수의 연구가 실험실을 넘어 실제 커피 현장에 어떤 영향을 줄 수 있는지를 보여주는 대표적인 사례로 꼽힙니다. 과학이라는 렌즈를 통해 커피의 세계를 다시 정의해온 크리스토퍼 핸든 교수. 오늘 우리는 그를 직접 만나 커피에 대한 그의 통찰과 열정, 그리고 연구의 핵심을 함께 들어보고자 합니다. 이번 영상은 총 3편 중 첫 번째로 그의 연구실에 대한 소개편입니다. 자, 그럼 시작합니다.
여기가 지금 오레건 주립대학교인 거죠?
네.
와, 너무 멋있고 너무 깨끗하고.
저기 오셨다. 저분이야, 저분.
저분이시네.
저기 오셨다.
감사합니다.
You designed this?
그렇지.
What is this?
Eagle.
That's an eagle. Very nice. That's nice. I like the colors too. Did you paint this?
Yes.
That's nice. What's this one? Oh, I see. So I'm gonna taste pink and purple in this one.
Yes.
So like fruity, floral, blueberry. Is it a natural coffee? No, it's washed coffee. Interesting. Okay. And what about this one? This is natural. Hyena?
Yeah.
What is hyena in Korean?
Just hyena.
Just a hyena. Yeah.
Same word.
Yeah, same
Yeah.
one. Yeah.
What's eagle in Korean? Okay, different. Optimizing, but also optimizing is kind of a bad word in American science because optimization is viewed not necessarily as basic science problem, but more of an engineering problem.
Yes.
And I'm in a basic science in the chemistry department, so we're trying to learn fundamental things that apply more broadly than just coffee.
Yes.
So a lot of the work we do has application outside of coffee. It just happens to be that coffee is the best application because it's an area that so many people work in.
Yes.
Yes.
But so yeah, a lot of our papers are how do you understand what happens when you grind coffee?
Yes, yes.
What happens when you push water through a bed of particles that are packed tightly together? That sort of thing. What I'm going to show you later on when we get downstairs is the stuff we haven't published yet, which is kind of the next generation of what we're going to be doing. We can measure what's in the cup, like the flavor, if you like, in real time.
Yes.
And we can also modify it after it's been brewed in real time.
Yes.
Yeah.
Can you measure flavor?
Yeah.
Oh.
Yeah. So I'll show you.
Oh, okay.
Yeah. So we got a new thing. So I haven't published yet. We've got one paper in review on it, and then the second one is a really big deal. The second one is taking me a little longer, but my papers are slow. I don't publish 100 papers on coffee. I publish one every 2 years. I try to be really thorough.
Yes.
Yeah.
And so this next couple are going to be really important, I think. But yeah, they're really good. The you've given me today are already really good, and they don't need to be made better. You know, in fact, I think that they taste great, and if they don't taste great, that's okay because that's why we like coffee.
Yes.
But there are some coffees that are really cheap,
Yes.
that are really not enjoyable.
Yeah.
And those coffees could be improved, and everyone would like that more.
Yeah.
And so that's sort of where I think if you lift the bottom up,
Yes.
that allows for less stress, less cost at the top.
Yes.
And also it allows people at the top to excel further because then there's more people spending more money on coffee. So So there's like an element of like, how do we save money? How do we improve quality? How do we make more money? But I don't make, I don't have a company. I'm here. Yeah, you make money. I do the science side.
Yeah.
Originally when I first started, we published this book many years ago. I'm sure you've seen this book.
Yes, I read this.
It's funny, the day that it published, I was living in Boston at the time. And this isn't the exact copy. I have one other copy. And I didn't know there was this, my wife, but she was across the hall in the apartment. And I didn't know her yet. And I didn't know what to do to say hello to her. So I gave her a copy of this book. And so not this one, but the one at home, I guess. And yeah, so to this day, what this book reminds me of is not coffee.
Yeah.
It's of my wife, meeting my wife. But
This book starts your upcoming baby next month.
yeah, that's right. That's right. Yeah.
Congratulations.
Yeah,
Congratulations.
thanks. It could be tomorrow.
Oh, really?
Yeah, it's we're in it right now. Yeah, if I get a phone call, it's time to go.
Thank you very much.
No, yeah,
Thank you.
until we stop working. Yeah.
Yeah.
So this was 2016, I guess, when we stopped printing this book.
Yes.
And since then, I guess lots of people
Yes.
have wanted this book.
Yes.
And I remember when we first wrote it, I didn't think anyone would actually read it.
Wow.
And since after that,
Yes.
that's what started me in copy.
Yes.
It's been so long now. It's almost 10, I think it's 10 years
10
since we
years.
published this book.
Yeah.
We have another version, and I was trying hard to finish it by December last year, but I am slower and more careful now.
Yes.
Yes.
And
Yes.
I guess I'm getting older is what it is. Yeah. Yeah. But yeah, my lab also works. My lab also works in other food and drink.
Yes.
So I care about American whiskeys.
Oh.
So I'm
Whiskey and wine.
yeah, wine. Yeah, so I have the wine here and
Wine
the
cellar.
yeah. So we basically, if it's something that humans like to eat or drink,
Yes.
I'm interested as to why.
Oh yes.
Chemistry.
Actually, brewing is the same way.
Yeah,
Coffee, alcohol, wine.
Yeah.
Yes.
yeah. There are. I mean, it's all the same. Hey, Doran. This is Doran Pennington. Here.
Hi. Nice to meet you.
Nice to
My
meet
name
This is Allison Luke.
I'm Luca. Nice to meet
Alice.
you.
This is their children.
Myself.
up?
Yeah.
They have given us 2 coffees. And the younger son has done the art.
Oh,
Coffee.
amazing. Oh, he's going to like that.
Natural processing, washed processing.
That's for me, that's for him.
This coffee. Yeah, he did the art.
Oh, nice.
Here.
Eagle,
cool.
eagle, and hyena. When Maxwell first competed in the World Barista Championship with me as a part of the team, 2014 was the water year that he did his competition,
Yes.
and we competed with a Aricha. Do you know Aricha mill?
Aricha.
Yeah.
I love coffee.
Me too.
Yeah.
So Aricha mill washed Ethiopian coffee
Yeah.
was his espresso.
Yeah.
And I remember that we did so well all the way to the finals.
Yeah.
And then in the finals, the judges decided that they didn't like the flavor of the Aricha. And I was like, and I remember seeing the feedback sheet.
Yeah.
And the feedback was the exact reason why we like Aricha.
Yeah.
They said it tastes like tea, it tastes like lemons, and it's like, okay,
Yeah.
this sounds great. So we can say this is also where our podcast is recorded right here. So there's not that many people who want to listen
Yes.
to talking about coffee papers. But at the same time, I think that we do a good job of making it accessible. Yeah, definitely worldwide. It's on Spotify, Apple Music, Apple Podcasts. We're going to try a few new things this year. It's me and Doran quickly doing shorter reviews of papers.
Yes.
So-
Yeah, I think at the start we were trying to find the most interesting papers and talk about the papers with people that would want to talk about them with us. The papers more as a backdrop to learn about someone's expertise and their area and role in coffee.
Yes.
These coffee people don't get to flex that as much as they want to, I think. And so then we get to talk about a scientific paper and it kind of plays off of what they know.
Yeah.
And that makes it a little bit more of a two-sided conversation.
Yeah.
Your research wide is very wide. research field is
Yeah.
very wide.
Yeah.
What is your actual major?
My actual major, I went to school to train as a computational chemist.
Yeah.
Chemist.
What is that?
Yeah, let me see if I can pull something up here. When you're doing chemistry, there's basically two types of chemistry. One where you know the structure
Yes.
in some way,
Yes.
and there's the other type where you kind of don't know the structure and you're doing some work to understand maybe what the structure is, or perhaps just using it, not worrying about what the structure is. My side of chemistry is very firmly on the, we know the structure, what can we do with this?
Yeah.
And so if you like all solids like gold or any glass or something like this, there's repeating units where atoms are bound together, and if they're repeating crystallographically, if they're a crystal, then we can shine X-rays at this thing and learn where the atoms are. And once we have that, a computational chemist can then go ahead and start to use the atomic positions and predict properties from those materials. So for example, this is a crystal structure.
Wow.
And this is, this piece repeats in three-dimensional space. And I'll give you an example of what that looks like. This crystal, there's several unit cells of it right there.
Yeah.
That object is only, that'll be only about 30 nanometers large, which is, that's well below what you can see. So you'd need hundreds and hundreds of these cells repeating before you'd be able to observe one. These materials, for example, this one's an interesting one. It's got big holes in it. And this is what Doran's PhD is on. So materials that have big holes in it, those holes can be used to catch and store gases like carbon dioxide. In his case, he's working with nitric oxide. And NO is an important gas because it causes your blood vessels to dilate.
Yes.
And so it's a small molecule that has therapeutic benefits.
It can also kill you.
Yeah, it is. Everything's toxic.
Yeah.
So, but it can basically, you need to be able to measure how much there is in the air, and it's a small molecule, so it's a challenging thing to do. So his PhD is on looking at materials like this that can detect NO at very low levels. At least,
메테리얼하고도 비슷하네.
yeah. So that's what I'm trained in I don't touch molecule. I don't go into the lab for this. It's all done on the computer. So we kind of the same way that people model the weather.
Yes.
Our weather.
Yeah. And then separately, my other half of my lab is in coffee. So that's a very unusual combination, actually.
Yes.
It was more common back in like 1920.
Yeah.
So in 1920, there was, maybe you saw the movie Oppenheimer.
Yes.
You saw this movie?
Yeah, I saw.
That's a great example.
Yes.
So Oppenheimer was a theoretical chemist
Yes.
and also did experiments.
Yeah.
He just happened to make nuclear weapons. It was like mainly calculations, math, writing down things.
Yeah, if you walk
재밌어?
down the hall and look at the
재밌네.
research posters here, there are always a few different projects in every lab.
Yeah.
Like no lab does one thing.
Yeah.
Every lab does maybe 3
Yeah.
to 5 different projects,
Yeah.
but they're usually all in like a little family.
Yes.
Ours happen to be really different, but I mean we're all still chemists in a research lab.
Yes. I read your article. It has some electricity,
Yeah.
water, physics, very complex.
We're going to taste it in a minute. So the electricity thing is the way that we can measure the flavors in the cup.
That is the way.
Yeah, and then we can modify the flavors with the electricity
By
too.
electricity.
Oh, that's with the water squirting on the beans?
Yeah.
But you've known about this for years, right?
Yes.
Yeah, it's the, our paper just did a thorough job.
Yes.
Did you read this paper?
Yes. Yes.
Oh, yeah.
I think in summer in Korea,
Yes.
is the static less bad
Yes.
because it's humid?
Yes.
We will go downstairs to the coffee lab and have some. How old are you?
Now 15 years old.
15. Okay, so you have 3 more years in school,
Yeah.
and then what?
I don't know.
Don't know yet. And how old are you?
11.
11. Okay, so you got a little longer in school. Yeah. What sort of roaster do you roast on?
Kilograms per single, 15 kilograms of blend coffee.
Okay, so you have 2 roasters.
Yeah, to roast and sample roaster is 뭐지?
Lowest
Roast. Roast.
Yeah, they're nice looking. Yeah, they yeah.
and very expensive.
Oh yes, they sure are. Yeah. All right, let's go downstairs. The baby is a boy.
Boy,
Yeah.
congratulations.
Yeah.
boy.
Yeah. Yeah. We're getting it's getting close to the time, so I have to turn on my phone onto noisy.
Yes.
This building is the interface between physics, biology, yeah. There's like astronomy,
Astronomy,
yeah, all the natural sciences.
natural science.
Yeah, and my lab is here.
Oh, is it espresso bar?
Yeah, no, that's my whole lab.
Oh,
Wow.
lab.
That's it.
Ah,
Yeah.
okay.
Yeah.
Your lab is real cafe.
Yeah. We so for the paper with the squirting of the water on the beans,
Yeah.
one of the reviewers for that paper
Yeah.
asked us to control humidity.
Yeah.
And this building is pretty big, so we couldn't control this room.
Yeah.
So we built a box, and we put the grinder in it right here.
좀
So
찝어주네,
we did the
사실.
experiments right here.
Grind in box.
Yeah. So this is it. This is the lab. It doesn't look like a lab, as you're probably.
Hand and coffee wrap.
Yeah, this is it.
11 to 12.
Yeah, that's what. So we give away coffee to anyone who comes by
Alright.
between 11 and 12. So
Professor,
Yes.
what coffee do you like?
I'm going to show you.
Okay.
I like washed Ethiopian coffee.
Wash.
Come have a look at this. So in here, this is our
Wow.
coffee library. This is
Yeah.
where we get all of our roasters from all around. Yeah, so you can see we've got James Hoffman.
Yeah, James Hoffman.
Oh,
We've got I don't know what all these are. A phenolic defect.
defect.
Yeah, it's good to have phenolic defect. I don't know. We've got Onyx.
Onyx.
Yeah. This is Passenger from we're Pennsylvania.
Pennsylvania.
We have some Tim Wendelboe in here. We will get out the Ikimo. Okay. 2 other students. This is Laurel and Caitlin.
Hi.
They're both in the coffee lab too.
Gangnam Style. Do you know Gangnam Style?
Thank you.
Gangnam Style sing. Yeah, Gangnam Style. Yeah. Our roster in there. Yeah.
Alice and Luke are visiting from Seoul. Their company is Coffee by Love Specialty.
I know one word
Oh,
in Korean. Kong, bean,
Yeah.
and
Their younger son,
Yeah.
whose name I've forgotten, did the art.
준혁아 와서 설명해줘. 빨리 해줘.
you did this.
Okay, so let's pull out the e-can. We have everything you could possibly need to brew coffee. So we're going to make some coffee. And this one is our chemicals and electrochemical stuff.
Wow.
There's nothing in these ones. There's just books and things. We'll go into the back room and I'll show you what's back there.
따라오세요. Follow me.
So this is a laser diffraction particle size analyzer.
Particle size.
So this is
Yeah.
for measuring the size of coffee dust.
Particle distribution.
Yeah. The way it works is it's a red and a blue laser,
Yeah.
and the particles pass by the laser shining this way.
particle
So you-
분자.
You put the dust here, it shakes through there and comes out a
커피
tube into
분자.
here, flies past the light there,
Wow.
and then the red light has a longer wavelength, so it will diffract around bigger objects.
Yeah.
The smaller objects, like fines, need a light that has smaller wavelengths, so the blue light diffracts
Blue,
around the
yeah.
smaller objects. And between them, this will cast the sort of like, when you shine a light, you get a shadow. This one, if the object is small, it casts a big shadow because the light bends around it, sort of like going like that. So the small objects cast a big shadow here. The big objects cast a small shadow. And this system then reports the size of the shadow as a diameter. So then we can count the number of particles and their size. Also in the room, we have Ikawa Pro 100 for roasting.
이카와를 많이 쓰네 미국에서는.
And then back here, not impressive, but we have our decent DE1 XL,
Yes.
which we need for some studies. We don't need much equipment.
Yeah.
So Doran's pulling out this is the potentiostat, which is just a device that applies a voltage and measures current. That you can do. It basically just is a way of measuring amount of electricity. And the reason it works, basically,
이해돼?
different molecules will react with electricity at different voltages. So chlorogenic acid will react at, let's say, plus 1/2 of a volt, so 0.5 volt. And caffeine may react at like 1.5 volt. So you can separate the two molecules and measure their populations separately. And you can do it in brewed coffee. So you can basically make the cup, you can taste it, and if you don't like it, you can adjust it. We're going to show you an example with some low quality coffee.
Yeah, raw coffee.
So we're going to do it with this one.
Oh,
Okay.
yeah, okay.
Yeah. So not something that we probably drink often.
Yes.
That's okay.
okay.
Yeah, we're going to also have some good coffee as well. So yeah. So let me prepare some coffee for us. So this is the Yakimo from Windlebow. We received it.
Windlebow.
Yeah, we received this coffee 6 months ago.
Oh,
Some of the coffees in there have been frozen for several years.
several years.
Yeah. We notice actually for some of the coffees that they get worse, and some coffees don't change at all,
Right.
which is interesting.
Yeah.
Yeah. Although we're not doing experiments on that. We probably should, but we need the coffee for other things. So
Can I send more copies to you by mail?
we will always
yes.
be grateful to receive coffee from you. Yeah.
I will send some copies to you.
The way it works in the lab, the way it works is that I mentioned that we have coffee hour and we give away coffee, and then we want other people to try the coffee that we're doing science with. So we use the batch brewer and we make some for everybody. So you get to see your brand being consumed by new people,
Yes.
but also it becomes part of the science that we're doing. So it's good for us. It's good for everybody, I think.
Okay.
I will send.
Static electronic.
So we have in the each of the grinders has different burrs in them. So these ones have the SSP burrs.
SSP bar.
Yeah, these ones have the Gorilla Gear burrs, which is a company out of New Zealand. So I have not brewed this coffee in a while. We'll see how it goes.
Alliations. 무슨 floral?
Floral?
Yeah.
Yeah, it should be. It's still pretty cold. So when it's cold, it doesn't smell like much. Yeah.
그러니까 cold 할 때 smell much 하다고.
It'll start smelling more now. Yeah.
Harvey.
So in the building that we're in right now, on the floor you can see the object. So this is a Nobel laureate, not from our department, Nobel laureate Richard Feynman. Yeah, Feynman. This is a Feynman diagram.
와, 얘도
So-
이쁘다.
And then there's also different objects around that are supposed to look sciencey. Oh yeah, hit him with the good stuff. The lab is primarily funded to study espresso, but actually, what you'll see in a minute is that the system we've developed is more general than just espresso. It applies to, in principle, all food, but for now, all coffee.